We're going to construct the ionic equation for the reaction that I've written over here, where chlorine is reacting with KBr and it's producing KCl and Br2. It's not a balanced equation. To balance it, there should be 2 KBr and 2 KCl potassium chlorides. Now, this is the equation where if you probably know that a more reactive group 7 element displaces a less reactive group 7 element from its compound. So chlorine displaces bromine, ends up forming KCl, and bromine is formed. Now, all of them are in aqueous state, and we have to write the ionic equation. Now, remember, I told you that when substances, acids, bases, and salts, when they are in aqueous state, they dissociate into ions. So it only applies to acids, bases, and salts, ionic salts. For example, chlorine over here is a covalent compound, so it's going to remain as it is. It's not an acid, base, or salt, so it will not dissociate into its ions when you dissolve it in water. The ions will not get scattered in water. KBr, on the other hand, is going to dissociate because it's a salt. KCl, the product over here, is also going to dissociate into its ions, but bromine over here is not going to dissociate into its ions because it's a covalent compound. It's not an acid, base, or salt. So only acids, bases, and salts, they ionize and dissociate into aqueous ions. So let's start with KBr, because KBr is going to dissociate. It's going to form 2 K plus ions and 2 Br minus 1 ions. Remember, you should be able to, because there's K, it's in group 1, it's plus 1, Br is in group 7, it's minus 1. So in aqueous state, the ions will dissociate and they'll get scattered in solution. The product is 2 KCl, that's also going to dissociate. It's a salt, so 2 K plus ions and 2 Cl minus 1 ions will dissociate, and they would be in aqueous state, and bromine would remain as it is because it's not an acid, base, or salt. It does not dissociate when you dissolve it in water. So this is your equation, and I've written the substances that dissociate into ions in aqueous state. I've broken them down and written them separately. Now I need to figure out, the second step is I need to figure out which ion is a spectator ion. So spectator ions are the ones that are not undergoing any change. So in this reaction, if you look carefully in this reaction, the ions that are not undergoing any change are, for example, chlorine over here is undergoing a change. It's getting converted into Cl minus 1. The other substance, Br minus 1, is also undergoing, it's taking part in the reaction. It's changing into Br2. But if you look at K plus 1 was in aqueous state initially, and in the product side, K plus 1 is still in aqueous state, which means that it underwent no change. Nothing happened to K plus 1. The ions were roaming around in solution in aqueous state. In the product, they're still doing the same thing, which means they didn't take part in the reaction, so they are spectators. Then they're just watching the reaction happen, not doing anything themselves. So we're going to remove these spectator ions from the equation. So this is the only spectator ion in this reaction. And I'm going to rewrite the equation now. It's Cl2 aqueous plus, and I'm writing the equation without the spectator ion. So it's the same equation, Br minus 1 aqueous, and my products are 2 Cl minus 1 aqueous plus Br2 aqueous. So this is my final ionic equation.